This is the 2014 Ordinary Level DCG, question C2 looking at structural forms, and this question relates to the hyperbolic paraboloid. So if we just have a look at the question first, the graphic on the right shows a multimedia player for streaming TV over the internet. The hyperbolic paraboloid shaping on the top of the unit is designed to prevent the users from placing objects on it. Figure C2 shows the projections of a typical hyperbolic paraboloid surface ABCD, which is rectangular in plan. Draw the given plan and elevation of the hyperbolic paraboloid surface and the project an end view of the hyperbolic paraboloid surface. So we just need to draw an elevation and plan of what's given and then draw an end view. So I've started to set up this question. So I kept it down to the bottom page. I'm using an A3 page, so keep it quite low if you're doing that. Line going this direction at 30 degrees, and this line here is at 60. And all I did then is measure 55 millimeters either side and draw two vertical lines until they intersected the lines at 60 and 30 degrees. And then coming back in towards the center. I have an XY line here where my elevation is on, and the elevation is up a small bit above, so it's 20 millimeters up for points A and C, so this is A and C, and B here is up 60, as is D. So just labeling all the points is important. So I just need to find the corresponding points. So measured up here at 20 and then also the 60 as well. So just going to join up the points. So A joins to B, which joins to C, which also joins to D. So that's part of the elevation and the plan where I have the outside lines formed. Now I need to find the generatrix lines, the lines that are going to form my curve. So they've divided this up into 5 equal parts. So that's what I'm going to do. I'm going to divide 5 equal parts along this line and along this line. So this line here, when measured, is divisible by 5. So I'm going to mark that off into 5 equal sections. So I'm going to use again red and blue pens just to distinguish between my different elements. So I found these red ones. Now I'm going to find the other ones that go the opposite direction here, so from A, B and C, D. So again, this line needs to be divided up into 5 equal parts. This time it doesn't divide in evenly. Just going to take a line off at any angle and mark off 5 equal sections. Join the last one to the end of the line that I want to divide up. And then just use sliding set squares to mark off the other points. So again, these lines are drawn at the 60 degrees, so it's based on a rectangle, so the ones on this side are going to be the same. So they're just got drawn at the 60 degrees. If it wasn't based on a rectangle and these were different sizes, we'd need to divide up both sides and then draw lines joining the two between. So there I have my elements drawn in plan for the line AD and BC, they're the red ones, and for the lines AB and DC, they're the blue ones. Now what I need to do is I need to find this, all of those elements up in the elevation. So I'm going to pick the red ones first, it doesn't really matter. So BC, I'm going to join this up. BC goes to here, the other end of that line, CD, is this one. So taking one at a time makes this a little bit easier. Same. Alright, that should be red. It works the same. So the way this is set up, they're going to end up on top of each other. So my blue lines down here and the red lines, they're going to line up. So I'm going to take the blue ones, start and finish, but the red ones would be the exact same, so they'll line up. So as they line up, you don't need to take both elements up. Now you can if you want. You probably need them for the end view. As you can see here, red and blue are both starting in the same position. So the red ones are also in the exact same position, so you don't need to redraw them up there. What we do need to do is we need to put in the curve now that is going to be sitting inside here. And to do that, you need to find point. You're going to draw a curve that's kind of going to be tangential to each of those points, or each of those lines. So what I like to do is find kind of halfway along each of these lines, and that's going to be the point that I'm going to work towards drawing to, except for points A and D. So if I kind of draw a line coming along that's going to touch off that point there, then come up to D, same, going the opposite direction, not coming into that point in the middle, touching that point there again, and then up to B. That gives me the curve here in the elevation. So again, just a quick recap on that. So in the outer part of this, the bit that's exposed to the top, we've got between here and here, I'm going to find halfway, and I'm going to use that much of find halfway. That's the point that I'm going to use to touch my curve off when I'm drawing. Next part of this question, we're asked to find an end view of the hyperbolic surface. So I'm going to draw my end view off on this side. You can draw it on the left side if you like. I just have more space this way. So standard practice for drawing our end view, points over to the extreme edge of the object, then up 45 degrees into the end view. A and C are up at a height of 20, and B and D, which also need to be brought over, are at the height of 80. So all of these heights can be taken from the elevation. So D is up here. That's point D. This is point B. And point A and C are at the same level here. So this is C, and over here is point A. So we can join these up now to the corresponding points. So C joins to C joins to D, and C also joins to B. A joins to D, and A joins to B also. So that gives me the end view set up at the moment. So now each of the elements in plan and elevation need to be brought so that they appear over here in the end view. That's going to give us two curves, one probably going this way and another one up there like that. We'll see how that turns out. So I'm going to take the blue elements first. So I'm going to bring them horizontal up my 45 until it intersects with the line AB. That's one end of it. Same thing for the other end of it, except this time it's on the line CD. So that's this one. I can do the same thing, and for the next one, across up onto the line AB, and same for the other end of that same line. Now you can also just take the heights directly from the elevation. So that height there is this one, and so on, so they'll continue on. And I'll keep doing this the same way that I have been doing it. So horizontal line will take two ones here now. So just make sure you're joining the correct line to the correct points. And the final blue one. So that's lines joined on AB and CD. AB and CD. Now we need to do the same thing with lines joining BC and AD, so the red elements. So they're again going to need to be brought over and up into the end view. The heights are going to be the same as they're in the elevation, but we can do them this way. So line has to come across. This is going to be at the same position here. So where this one came up, that's 1 point. The other end of this line, which I don't have yet, on the line AD, it's going to be that point up there. So on the line CB to the line AD. Do the same thing for the next one. So this point. So it's a bit repetitive, but it's very doable. So onto the line CB first. That point, and then the line AD. So here to here. And just one more. And I already have that point. So again, just going to draw the best curve that we can, starting here somewhere, touching off halfway along here, and then it's going to come around on each. And there we have it. That is the 2014 ordinary level C2.